Hi, these are the answers to Blue Workbook pages 58 through 60 that are dealing with molarity and parts per million calculation. We are going to start with set A, question number 1, where we have the definition of molarity and parts per million. And if we go on our periodic table, we are going to see that molarity is equal to moles of solute per liters of solution. And we're also going to see parts per million is equal to the mass of solute times a million, that goes in the numerator, over the mass of solution. So what I need you to understand over here, it can get a little tricky, especially if you do more calculations later on, where you have to calculate the mass of solute. You have to extend that line and understand that 1 million goes on the numerator over the mass of the solution. So we're going to go back to over here, let's clear. And we are going to write that molarity. And when we write molarity, the unit for molarity is a capital M, not MOL, but molarity is capital M, is equal to moles of solute over liters of solution. And when we have to write parts per million, we don't write parts per million, but in short, we're going to write ppm. So parts per million is equal to, and we're going to go back. I just want you to be able to see. You're going to see mass of solute times a million over mass of solution. So we're going to write down mass of solute times a million over the mass of solution. Okay, so we multiply. Let's clear. Let's move that. And let's go down here and let's do question number 3, easy calculations. These calculations are dealing with the calculation of molarity. And we're going to remember molarity is equal to moles over liters. Moles of what? Of solute over liters of solution. And remember, when we have a solution, we have the solute, the smaller part, and the solvent. So for example, if my solute is 1 gram and my solvent is 1,000 grams, my solution is 1,001 grams because my solution is made up of both the solute and the solvent. So over here, we're asked to calculate what is the molarity. Right away, we're going to write the definition of molarity. Okay, moles of solute over liters of solution. How many moles of solute do we have? 1 mole. How many liters? 1 liters, which is equal to 1 molarity. Let's go over here to question number 4. Again, what is the concentration? Now here, they're not telling us molarity. Here it's very, very clear. They're telling us it's molarity. But here it's concentration. So if I go back, let me just clear all this. And I just want to go back and I want to show you that you have, when you are calculating concentration, you can calculate concentration in either parts per million or molarity. And it all depends on what you have. And if they're not specific, they can either say, okay, calculate concentration in parts per million or calculate concentration in molarity, okay? But sometimes when they're not gonna say, you're gonna determine what they're asking based on what information is given to us. Let's go back and let's go over here. And over here, they're asking concentration. And what are they giving me? They're giving me moles of solute and liters. From the definition, we know what was molarity. Molarity is moles of solute per liters of solution. So therefore, Because I have moles and liters, I can calculate molarity. Moles over liters. How many moles do I have? 0.5 moles of solute. How many liters do I have? 1.8 liters. So when I go on my calculator and I divide 0.5 by 1.8, so I'm going to put on my calculator 0.5 division 1.8, enter, I will get a 0.28 molarity. Please do me a favor. Calculate this and make sure you get 0.28, because sometimes students inverse these numbers and they write the wrong answer. Let's move on to question number 5. Again, what is the concentration? They're not specifying how to measure the concentration. They're just saying concentration. What are they giving us? Moles and liters. What am I going to do? Molarity is equal to moles over liters. How many moles do I have? 3.3 moles. How many liters? 6.0 liters. I'm going to divide 3.3, division sign, 6.0, and I will get 0.55 molarity. You see, the unit is capital molar. Whenever we see that capital molar unit, capital M, that means molarity. Again, what is the concentration? They're giving us moles and milliliters. So now it's moles over liters. How many moles do I have? 2 moles. How many liters? Well, I don't have liters, but I have milliliters. I know how to convert. I know, and you have written it on your periodic table on the front page, that 1 liter is equal to 1,000 milliliters. So I'm going to take my 500 milliliters. I know that 1 liter is 1,000 milliliters. Milliliters and milliliters cancel out. 500 times 1 is 500, divided by 1,000, it's 0.5 liters. So I have 0.5 liters, and when I divide that, I will get 4 molar. That's the answer. Let's go to question number 7. Again, they're giving us milliliters and moles. Molarity is equal to moles over liters. How many moles do I have? 3.0 moles. How many liters? Well, they're giving us 1,500 milliliters. I'm going to convert using dimensional analysis. You know that 1 liter is equal to 1,000 milliliters. Milliliters and milliliters cancel out. 1,500 divided by 1,000 is 1.5 liters. So I have 1.5 liters. And when I divide 3.0 by 1.5, I get 2 molar. Now, this is a slightly different problem. They are asking for molarity. So molarity is equal to moles over liters. And here they're giving me the liters, 2.0 liters, but we need moles. What did they give us? They gave us 28 grams of NaCl. I have grams. Can I calculate, can I convert grams to moles? Yes. Let me clear. And let's go back to our reference table. And let's go over here. We're going to have to use mole calculations. So moles is equal to mass over GFM. So moles is equal to the mass that it's given to us over GFM. Let's go back. And let's go ahead and answer question number 8. So molarity is equal to moles over liters. I have 2, sorry, I don't have. I have 2 liters. I need moles, but I'm given grams. What's the formula? Moles is equal to mass over GFM. Well, what mass do I have? Mass is measured in grams. I have 28 grams of NaCl. What do I need? I need to calculate the GFM for NaCl. Well, let's review. Na, I have 1. Cl, I have 1. I'm going to go on my periodic table. I'm going to look at the mass of Na, which is 22.987. I'm going to round it to 23. I'm going to go to chlorine. I'm going to see that it's 35.45. So I'm going to do 35. I'm going to simplify the math. And I will say it's 23. 1 times 23. 1 times 35 is 35. That is equal to 58 grams per mole. So I'm going to do over here 58 grams per mole. And when I divide 28 by 58, I get, so 28 by 58, I get 0.483 moles. Now that I have my moles, I'm going to put them over here, 0.483 moles. And when I divide these two, I get 0.241 molarity. So this is slightly different. Let's go on question number 9. What is the molar concentration? That's another word that you're going to see. What did they give us? Whenever they're asking for molar concentration, they're asking the concentration in terms of molarity, molarity. Therefore, molarity is equal to moles over liters. And I do see that I have 1.5 liters, but I don't have moles. What do I have? I have again what? Grams. So I'm going to remember moles is equal to mass over GFM. I have to find the moles of potassium sulfate. How many grams do I have? I have 522 grams. I need to calculate the GFM for K2SO4. So K, S, and O, 2, 1, and 4 times potassium. Potassium has a mass of 39. Sulfur has a mass of 32. And oxygen has a mass of 16. So 2 times 39 is equal to 78. 1 times 32, 32. And 4 times 16 have a mass of 64. I'm going to add 64 and 32 and 78. And we are going to get a mass of 174 grams per mole. I'm going to put this one over here, 174 grams per mole. Next time I'm going to do these calculations for the mole in a different color. So I'm going to divide 522, division sign, 174, and I will get 3 moles. Now that I have my moles, I'm going to put them over here. Okay, let me just erase that arrow. And when I divide 3 moles by 1.5, I get 2 molarity, capital M. That's the answer. Let's go over here, number 10. What is the molarity of a solution? Molarity is equal to moles over liters. How many moles do I have? I don't know. I have grams, so I have to calculate them. I don't have liters, I have milliliters, so I have to do a couple of calculations. I'm going to take my 500 milliliters. Actually, let me do this calculation over here. So I'm going to take my 500 milliliters and I'm going to change them to liters. And I know that 1 liter has 1,000 milliliters, milliliters and milliliters. So I see that if I divide 500 by 1,000, I get that I have 0.5 liters. I calculated my liters. Now I have to calculate my milliliters, my moles. And what do I know? Moles is equal to mass over GFM. What mass do I have? 12 grams. What do I need? I need the GFM of HCl. I'm going to go over here. qualitative information, 8 in CL, quantitative, 1 of each, times 1 times 35, 1 and 35, it's 36 grams per mole. So 36 grams per mole. I'm going to divide 12 by 36, and I'm going to get 0.333. I'm going to put the 0.333 moles over here, and I'm going to divide them by 0.5, and I should get 0.6666. I'm going to round to this one, molarity. And that's the answer. So here we had to convert our milliliters to liters, and we had to convert our grams to moles. Let's move on to the next page. Page number 59, question number 11. Now this is slightly different because it's asking you for the moles. And what are they giving you? You see that capital unit? That's molarity. Molarity is equal to moles over liters. So let's go ahead and see. They gave me molarity. What molarity did they give me? 1 molar is equal to, they're asking me for moles, and they're giving me how many liters? 2 liters. So now I have to calculate moles. And now I'm going to see that moles, or whatever I have to calculate, my X, you want to write moles? You want to put X, whatever you want to do, is on the right side. So we have to bring it on the left side of the equal sign. So what I'm going to do is I'm going to put over 1 over here, and I'm going to cross multiply, and I'm going to just do this one in a different color to show you. So I'm going to do cross multiplication. Moles times 1 is equal to moles. It's 1 times 2. So moles is equal to 2. 2 moles. And you're going to say, but I don't understand here. Well, let me just show you. This is 1 molarity. What is 1 molarity? 1 mole per liter. What happens to liters and liters? They cancel out. What are you left with? Moles. So mole is equal to 2 moles. That's the answer. Let's go on question number 12. They're asking us again for moles. What did they give us? Liters and molarity. What do we have? Molarity is equal to moles over liters. So molarity is equal to moles over liters. What molarity do I have? 2. So that goes over here. Is equal to moles, or X. This time I'm just going to put an X, just so that you can see you can either write moles or we can say X. But I like to write moles because then I know what I'm looking for. I'm looking for moles. If I have X, it can be confusing. And then how many liters do I have? 1.5. Where do they go on the denominator? 1.5. I'm going to put 1. And what am I going to do? I'm going to cross multiply. So 1 times X is equal to 2 times 1.5. So 2 times 1.5. So X is equal to 3 moles. See, when you have X, you have to say, oh my God, what am I calculating? Moles, liters, molarity. But when you have moles, you say, oh, I'm calculating the moles. Let's do number 13. Again, it's a mole problem. They're giving us, so molarity is equal to moles over liters. They're giving us the molarity to be 1.5 is equal to moles. I am looking for them over 2 liters. Again, cross multiplication. Moles is equal. Let me just change color so that you can see the cross multiplication. Is equal to 1.5 times 2. Therefore, moles is equal to 3. Let's go ahead and do number 14. Again, the same type of problem. This is has an extra step because they're asking us for moles. They're giving us molarity. So we know molarity is equal to moles over liters. My molarity is 0.4. I am looking for moles, but you're going to notice you don't have liters. What do you have? Milliliters. So you have to do that extra step. You know that 1 liter has 1,000 milliliters. Milliliters and milliliters cancel out. 200 times 1 is 200 over 1,000. It's 0.200 liters. What am I going to do? I'm going to cross multiply. Moles is equal to, I'm going to use a different color. 0.4 times 0.2. And when I multiply this, I get my moles to be 0.08 moles. Let's go on question number 15. Now before we calculated moles, now we have to calculate volume. So now it's a little bit more like there's an extra step, but it's the same procedure. I'm going to write molarity is equal to moles over liters. They gave me my molarity to be what? 1.5 is equal to, they're giving me the moles to be 2. What are they asking us? 4 liters or X. What am I going to do? I'm going to cross multiply. I'm going to use a different color. I'm going to do 1.5 times liters is equal to, I'm going to do a different color, 2 times 1. Now I need to solve for liters. I'm going to divide by 1.5 and 1.5. And I'm going to get liters, or X is equal to 2 divided by 1.5, which is, I think it's 1.3. 2 divided by 1.5. 1.3, yep. 1.3 liters. If that liters confuse you, you can put X for liters. So let's do this one by using for liters X. How much volume? So how many liters? Because they're giving us molarity and moles. So molarity is equal to moles over liters. What molarity do they give me? 0.4, so it goes over here. How many moles are they giving me? 0.12. And they're asking for liters. So I'm going to put an X because it's easier here, because if you put liters, you're going to confuse it for a unit, not what you're looking for. What am I going to do? I'm going to cross multiply because my X is over here. So I need to cross multiply. So I'm going to do 0.4 times X is equal to 0.12 times 1. I'm going to divide by 0.4 and 0.4. So X is equal 0.12 times 1 is 0.12 divided by 0.4 gives us 0.3. 0.3 what? What's the unit? Well, what am I looking for? I am looking for liters. And that's why my X is over here. So therefore, my X, if I'm looking for liters, my 0.3, the unit is liters. Let's go on question number 17. Again, what volume of a 0.3 molar solution will contain 0.75 moles of the solute? So again, we're going to write molarity is equal to moles over liters. My molarity is given as 3. The moles are 0.75 and volume liters is going to be X. Let me change colors. I'm going to, actually let me do this first. So clearly it's 3X is equal to this one now, 1 times 0.75. I'm going to divide both sides by 3 to leave X by itself. So I'm going to put in a calculator, 1 times 0.75, enter, which is 0.75, divided by 3 It's equal to 0.25. Now, what's the unit? I'm calculating X. What's the unit? Well, what is X? X is liters. Okay, so it's liters. Here it's asking for milliliters. Molarity is equal to moles over liters. What's the molarity? 2.5. How many moles do I have? 1.25. What am I going to calculate? I'm going to calculate liters. I'm going to cross multiply. I'm going to do first this one. 2.5 times X is equal to 1 times 1.25. So that's 2.5x is equal to 1.25. I'm going to divide both sides by 2.5 and 2.5 to leave x by itself. X is equal to 0.5 liters. 1.25 division sign, 2.5 enter in the calculator is going to give me 0.5 liters. Now I'm not done over here. What did I calculate? I calculated liters. What do they want? They want milliliters. So I'm going to take my 0.5 liters, and I know that 1 liter is 1,000 milliliters. Liters and liters cancel out. 0.5 times 1,000 is 500. Divided by 1, 500 milliliters. So the answer over here is, let me just do it in a different color, it's 500 milliliters. So first you calculated 0.5 liters and then you converted it to milliliters. Let's move on to the next one, number 19. How many grams? So now these are a little bit more complicated. We calculated moles, we calculated liters. Now they want us to do grams. So we're going to do, again, they give us molarity. The moment we see capital M, we're going to write the formula. Molarity is equal to moles over liters. What molarity do they give us? 0.5. That goes over here. Is equal to moles. That's the only thing. And they give us the 1.0 liters. And therefore, I'm going to do again the cross multiplication. I'm going to calculate moles, or X, you can say, is equal to 0.5 times 1. So moles is equal to 0.5 moles. Moles of what? CaCl2. But they're not looking for moles of CaCl2. That's your solute. That's what's added into water. They want grams. I am going to use my formula. And let me just change colors. Moles is equal to mass over GFM. So on the first thing we had to calculate the moles. We cannot stop because we calculated moles. Now they want grams. How many moles did I calculate? Well, I calculate to be my moles from over here, from this step, 0.5 moles. What am I looking for? I'm looking for mass. I'm looking for grams. Grams is mass. What do I need to calculate? I need to calculate the GFM. So let's calculate the GFM of CaCl2. Qualitative is I have calcium and chlorine. Quantitative is I have 1 calcium, 2 chlorine. Calcium has a GFM of 40, a mass, and chlorine 35. I'm just going to round it. 40 and 70 is 110 grams. Grams per mole. Where is that going to go? 110 grams per mole. I have to solve for mass. I have to solve for grams. Let me just change colors so that you can see it. I'm going to put 1 and I'm going to do my cross multiplication. This is all algebra. Mass is equal to 0.5 times 110. 0.5 by times 110 is 55 grams. That's the answer. So the answer to this one is 55 grams. So there were 2 steps. First, we calculated the moles. And then we change the moles to grams by using these formulas. So 2 formulas. Let me clear the work so we can work on the next one. Again, they're asking for grams. What do they give us? Molar. Whenever we see the word molar, it's molarity. Molarity is moles over liters. What is the molarity? 1.5. What is the moles? I don't know. I'm going to put X. How many liters do I have? 2.3. From here, I'm going to cross multiply. I'm going to say X times 1 is X is equal to 1.5 times 2.3. So I'm going to do this. So X is equal 1.5 times 2.3 is equal to 3.45 moles. But I'm not looking for moles. Moles of what? Of NH4, NO4. I'm looking for grams. What formula am I going to use? I'm going to use the formula moles is equal to grams over GFM, or mass over GFM. How many moles do I have? Well, I have 3.45. I'm going to do this over here. Is equal to grams or mass. I have to calculate the GFM of NH4 and NO4. I have nitrogen, hydrogen, and oxygen. This is interesting because I need you to realize you have nitrogen here and nitrogen here. So you have 2 nitrogens, 4 hydrogens, and 4 oxygens. Nitrogen has a GFM of 14, hydrogen has a GFM of 1, oxygen has a GFM of 16. 2 times 14 is 28, 4 times 1 is 4, and 4 times 16 is 64. 64 plus 4 plus 28 gives us a GFM of 96 grams per mole. I'm going to write that one over here, 96 grams per mole. I'm going to cross multiply. I'm going to use a different color so that I can show you. So grams, or X, is equal to 3.45 times 96. 96 times 3.45. It gives me a mass of 331.2 grams. Let's move on to the last page of our problems. Now we're working with parts per million. So we're working with ppm. So I'm just going to go ahead and write the formula from the table T, which is the mass of solute times a million over mass of solution. So what is the concentration in parts per million? So I have to calculate ppm. When 10 grams of solute, what is my mass of solute? 10 grams. Times what? From the formula, times a million. Over the mass of the solution. What did we say our solution is? Our solution is made up of 2 parts. It's made up of the solute and the solvent. My solute in this case is what? 10 grams. My solvent is water, is 2,000 grams. So my solution is 2,000 from the solvent and 10 grams from the solute is 2,010 grams. So 2,010 grams. You have to be careful. Sometimes they're going to give you both. They're going to give you the solution, or sometimes they're going to give you the mass of the solute and the solvent. If they give you the mass of the solution, you just put it over here. If they give you the mass of the solute and the solvent, then you add them up. So we're going to go 10 times a million divided by 2010, and we get an answer of 4,975 parts per million. We're not doing it in the correct number of significant figures. If we were, we're going to do it in one, it would be 5,000. Let's go over here, number 22, parts per million. Again, mass of solute. What's your solute? It's 0.2 grams, 0.02 grams, times what? Times a million. Over mass of solution. They gave me the mass of the solution. They told me it's 500 grams of solution. So 500 grams. So I'm going to go ahead and do 0.02 times a million divided by 500. And I will get 40 parts per million, 40 ppm. So 40 ppm. That's the answer over here. Let's go again and do them. This is very, very simple. Don't let the math or the big numbers times a million confuse you. So again, parts per million. What is the concentration in parts per million? So ppm is the mass of solute. Which one is my solute? My solute is my smaller part. So that's my solute. It's 0.5 grams. Times what the formula says? Times a million. Over the solution. What did I say the solution is? Oh, it's 1,000 grams. So we're going to do 0.5 times a million divided by 1,000. And we're going to get an answer of 500 ppm. Please do me a favor, work the answers, put the numbers in your calculator, and make sure you get the right answer. Don't just assume, because students have the setup correctly, but they put the numbers in the calculator the wrong way. So you have to confirm that you know what you're doing and how you put in the numbers. Again, what is the concentration in parts per million? So ppm is equal to mass of solute times a million over mass of solution. Nice and simple. So ppm is equal to the mass of solute. What's the mass of the solute? My solute is my smaller part. It's my 100 grams times a million over mass of solution. Now, it doesn't say 2,005 grams of solution. It says 2,005 grams of water. What do we say our solution is? Our solution is our solute, the smaller part, and the solvent. What is my solute? 100 grams. What's my solvent, which is almost always is going to be water? 2,500. So my solution has a mass of what? 2,600 grams over 2,600 grams. So I'm going to go ahead and put in the calculator. I'm going to do 100 times 1 million. That is equal to 1, and how many zeros? Let me see, 1, 2, 3, 4, 5, 6, 7, 8. I could just add the zeros, but I just want to show you. 4, 5, 6, 7, and 8. And it's 1, 2, 3, comma, 1, 2, 3, comma, over, let me just erase this. Okay, so it's a 100 million over 2,600. I'm going to divide that by 2,600. And I will get an answer of 38,000. I'm no, sorry, 38,000, yes, 462 parts per million if I round up. Let's move on to the next one. Final 4 problems. What is the concentration in parts per million? Parts per million. Mass of the solute, the smaller part, 2.7 times 10 to the negative 2 grams times what? A million. That's why it's parts per million. Over 3,800 of tank that contains. So I know it says water, but the whole fish tank contains a mass of 3,800. And that includes the water, and inside the water we have the oxygen. So when we do the setup, when we do 2.7, now this is how you're going to do 2.7, 2.7 second E to the negative 2 times a million. It's 0.027 times a million. You get 27,000 divided by 3,800 or 3,800. You should get a parts per million of 7.1 ppm. So this is going to be a challenge on how you put it in the calculator, and I've shown you in class on how to do this. Now, these problems, they're slightly different because they're asking for how many grams, and how many grams, the mass of the solute. So they're asking for the mass of the solute. So ppm is equal to mass of solute times a million over mass of solution. They gave me the ppms. How many ppms do I have? 2 is equal to, they're asking me for the mass of solute times a million. There's the math, the algebra that can get a little tricky. Over 1,000 grams of solution. So I'm just going to change the color over here, and I'm going to have to do the cross multiplication. So I'm going to say mass of solute times a million is equal to 2 times 1,000. 2 times 1,000. I'm going to change the color because now I want to show that I have to divide by both by what? By a million. Why am I dividing by a million? Because I just want to leave the mass of solute by itself. But if I divide this side by a million, I have to divide that side by a million. So it's going to be 2 times 1,000. It's going to enter. That's going to give you 2,000. 2,000 divided by a million, it should give you an answer of 0.002 grams. That's the answer. Make sure you put these and you get these numbers. Number 27, again, ppm is mass of solute times a million over the mass of solution. How many ppms do I have? 0.5 is equal to the mass of the solute. I'm looking for that. Times a million. Over the mass of the solution. What is the solution? 2,200 grams. Just going to change color so that I can show that. So mass of solute times 1 times a million is equal to 0.5 times 2,200. I'm going to divide both sides by a million. So I'm going to do 0.5 times 2,200, 0.5 times 2,200. It's going to give me an answer of 1,100. 1,100 divided by 1 million. It's going to give me an answer of 0.0011 grams. That's the answer. Finally, let's do the last one. Let me just clear so that it looks nice and neat. Number 28, ppm is equal to mass of solute times a million over mass of solution. How many ppms do I have? 1.5 is equal to mass of the solute. That's what I'm looking for, times a million. You can put X, you can put mass of the solute over the mass of the solution, 1,500. I'm going to cross multiply. So 1 times X times 1,000,000 is equal to 1.5 times 100, 1,500, 1.5 times 1,500. I'm going to divide both sides by 1,000,000. What I do on one side, I have to do to the other. And X is 1.5. 1.5 times 1,500 gives you a number of 2250. Divide that by 1,000,000. And you should get 0.00225 grams. So the answer is 0.00225 grams. And that's the end of this homework. I hope you enjoyed it. I'll see you in the next video.